Welcome. AP video 3.2. Here we're looking at the mole and counting. The main objective here is to be able to convert between moles and mass, and also the number of particles. Just a friendly reminder to turn off your cell phones, put them away. Turn off that social media so you can focus. Pause, rewind frequently, and take some notes in the margins or some extra notes or questions if you have any. Let's go. So, why do we care about the mass of each atom like in the last video? Well, it would take forever to count all the atoms in a sample. So we're going to mass to count, kind of like this. A pile of marbles weighs 394.80 grams. If 10 marbles weigh this many grams, how many marbles are in the pile? Well, it's going to be a lot quicker to use a little math ratio here to figure out how many marbles are in this rather than count them all out. So if the average mass using the 10 marbles weighs 370.60 grams, we get the average mass gram per marble, kind of like we're about to do. We're going to say the average mass of an atom here in a mole. We can use that average mass now, and if you divide out the total mass by the average mass of a marble, you get approximately 105 marbles. It's a really quick way to count. It's faster to, let me back up now, it's faster to mass something, which allows us to count rather than count things out. Okay, so because a sample of matter contains so many atoms, a unit of measure called the mole has been established for counting particles. The abbreviation for the mole is MOL, and is the number equal to the number of carbon atoms in exactly 12 grams of pure carbon-12, back to that standard of carbon-12. It has been determined, and this is important now, that 1 mole equals 6.022 times 10 to the 23rd particles. And from last year, we added one more number here. At the AP level, we actually go to have 4 sig figs in this number here. All right, so this is our conversion factor. So if you know how many particles you have, you can convert that to moles. And just a quick little recap on particles. Particles are like atom particles. So if you have an element, you have atoms of that substance. If you have a covalent compound, you have molecules. That's the particle name we're going to use. If you have an ionic compound, we're going to use the formula unit. And if you're talking about like polyatomic ions or monatomic ions, you have ions. And don't forget that atoms, which is typically elements, there are the 7 diatomics that are actually molecules. So H2 is a molecule, N2, O2, F2, Cl2, Br2, and I2. Those are your 7 diatomic molecules. All right, let's move on. So, in addition, we also have a thing called molar mass. And because mole is defined the way it is, 1 mole equals 6.022 times 10 to the 23rd particles. It's defined this way. It also means that molar mass, which is the mass of 1 mole of a substance, it's actually equal to the atomic mass. And the atomic mass, don't forget, comes from the periodic table. I wrote that even right here. Okay. So if you have 1 mole of substance X, you have this many particles, right? That's what a mole is. Well, given the periodic table, if you find the mass of that element on the periodic table, that's how many grams there would be if you had 1 mole of that substance. So for example, let's look at the periodic table quick. Alright, so we'll pick on iron because we all know I like iron. So here's iron right here, 26 iron, and its atomic mass is 55.85. Okay, so what that means then, 55.85. If I were to weigh out 55.85 grams of iron, that's the mass of iron from the periodic table, that then means I have 1 mole of iron. And that also means I have 6.022 times 10 to the 23rd atoms of iron. That's really our big connection here in this chapter here. Atoms. Okay. The molar mass off the periodic table means you have 1 mole of that substance, which means you have this many particles. And because they're all equal to each other, kind of like we're saying A equals B equals C here, they all equal each other, we can put those things into a conversion factor. Like you can have 55.85 grams of iron on top and 1 mole. And this would be a conversion factor to cancel out mole. And then you would convert into grams of iron. We could flip this fraction over, and that would allow us to go from grams to moles. We could also combine the grams and the particles here together in a conversion factor. So that's kind of where this is all going, I guess. Alright, so here's a quick practice problem now. Here we're looking to compute the number of moles and the number of atoms of a 10-gram sample of aluminum. Okay, so I think by now, from last year in chemistry, we should know that grams, mass, is something you can convert into moles, and you can also convert it into atoms. So let's go ahead and do our two calculations here. So if you start with 10 grams of aluminum, you can go directly into moles from that, so you can go grams on the bottom and into moles like this. And I like to put my units in first to make sure they're in the right spot. And then the relationship here, don't forget we call this the molar relationship, so in this case this is molar mass. And we found out on this video here that 1 mole of aluminum is equal to the mass off the periodic table, grams of aluminum. So if we go to our periodic table, aluminum is right here, and it's 26.98. So you have 26.98, and now we have 10 divided by 26.98, which equals 0.371. Oops. 0.371 grams of aluminum. And I did round it to 3 sig figs because we have 3 sig figs here. I only had 4, so 3 sig figs. That's how much grams of aluminum you have if you have, I'm sorry, not grams, Mr. Schultz. See, that's why we want to cancel our units out here. That's how many moles of aluminum we have. Now we can do the exact same thing and convert this grams now into how many particles of aluminum that is, how many atoms of aluminum. So in this case, we're going to convert grams right into atoms of aluminum, how many particles we have of it. Okay, and their relationship goes back a slide here for a second. Whoops. Okay, so the mass, we'll actually say aluminum here now. The mass of aluminum is equal to 1 mole of aluminum, and there's this many atoms of aluminum. So these two things are also equal to each other. I'm going to have to put a different number here because it's got a different mass for aluminum. But basically we're going to put those things in and convert. So we already know the molar mass. We looked up off the periodic table. When you have 26.98 grams of aluminum, that represents having 6.02 times 10 to the 23rd atoms of aluminum. And just a quick reminder that this number here is referred to as Avogadro's number, since he's kind of the guy who started the work on trying to find that number. And it's capital N, lowercase a like this. That's another symbol you can use for that number in case you get sick of writing it. So we have 10 grams times this number divided by that number. And if we multiply that together and do the division there, we end up with, whoops, I did it again. We end up with 2.23 times 10 to the 23rd atoms of aluminum. Alright, and we got one more practice problem here for you to do. And this is one I would like you to try on your own. And I'll have you actually put your answer into Edpuzzle here, and then I will check the answers to see how we're doing this stuff. And when you're done, you'll actually get to unpause and see the answer as well. So you need to figure out how many atoms of silicone there are in 5.68 milligrams. And I'll give you a quick little clue here. Watch out. You can convert grams into moles. Are you in grams? Alright, good luck. Okay, so by now you should have done the problem, put your answer in. So here's how you do this one. So the first thing you want to do is convert 5.68 milligrams into grams, because you have to convert grams into moles. Milligram represents 10 to the minus third, and we're going to convert this into grams, which represents 10 to the 0. It's a base unit. Okay, so we're going to kind of go up to a bigger unit here, and when you go up to a bigger unit, the number gets smaller because grams represents large numbers of these things. So we're going to end up moving it 3 because there's 3 steps between these two things here. And if you remember the stair-step method as well, milli be down here, the base is up here, so we're going up and to the left. So 3 to the left. So 1, 1, 0, 2 zeros. So we actually end up having 0.00568 grams of silicone. And now to convert that into atoms, I can go grams into atoms in one step if I know the molar relationships, which is there is Avogadro's number's worth, 6.022 times 10 to the 23rd atoms of silicone. When you have, I'm trying to think off the periodic table, I think it's 28 point something, I forgot. I'm a little rusty right now. 28.09. 28.09. So multiply the tops, divide by the bottoms, and you end up with, 1.22 times 10 to the 20th atoms of silicon. Alright, good job everybody.